Hello everyone, my name is Lufia Chatsi, research scholar of Christ deemed to be University, and here I am presenting my implementation paper entitled by Unbalanced Dataset Preprocessing Using Hybrid Combination Algorithm for Arrhythmia Detection. So abstract. Timely prediction of cardiovascular diseases with the help of the computer-aided diagnosis system minimizes the mortality. We know that nowadays cardiac arrhythmia detection is one of the most challenging tasks because the variations of electrocardiogram signals are very small, which cannot be detected by human eyes. Arrhythmia is a condition of abnormal rhythm. In this study, a new convolutional neural network model is proposed for classification of the MIT BIH arrhythmia dataset, and which will be divided into 5 classes. Here addresses the challenge of the class imbalance in the analysis of arrhythmia data, utilizing the hybrid combination of three approaches like Tomke-Link's, Resbus classifier, and Edazin. Here we have used the three hybrid combination of these methods. Additionally, here provides a thorough analysis of new preprocessing model approaches for diagnosing the heart disease. By comparing the performance of these methods, this research contributes to the development of the robust and accurate arrhythmia classification models with the potential applications in clinical diagnostics and healthcare decision support system. Here I am showing the overall diagram of my project arrhythmia detection. The first phase is the database acquisition, and second one is the data preprocessing. That means the combination of Tomke-Link's, Edazin and Resbus classifier. As a result, we will get the balanced data. The balanced data means from here we can remove the near class boundaries, and we can generate the synthetic samples, and we can calculate the error. That means the weighted error. After that, the balanced data will be given to the train and test splitting section. As a result, we will get two kinds of the data. The first one is a train data and second one is a test data. After that, we can create the model building, and finally we can evaluate the result. That means we can check the result, or we can find out the first input is affected by the arrhythmia, yes or not. As I told earlier, here I am using the combination of three methods such as Tomke-Link's, Resbus classifier and Edazin. According to Tomke-Link, which is a techniques employed to address the class imbalance within the dataset, and which is mainly aims to improve the quality of the training data by reducing the overlap between the different classes. And this algorithm then selectively removes the instance from the majority class in each pair. And the second method is the Resbus classifier, which means the random undersampling with boosting, which is an overlapping technique designed to address the class imbalance by generating the synthetic test for the minority group. And this approach ensures that the synthetic samples are generated, capturing the underlying data distribution more accurately. By balancing the data and emphasizing the importance of the minority class, DressBoost equips the model with the necessary tools to make the accurate predictions for the arrhythmia detection. And the last method is the Edazin, which means the adaptive synthetic sampling method, which is the combination of two powerful techniques, and this technique strengthens of the Edazin lies in its adaptability to the local distribution of the data, and the effectiveness of the Edazin may change depending on the specific characteristics of the dataset, and the careful tuning of the parameters may be necessary to achieve the optimal results. This is the hybrid method. In this hybrid method, the input will be the MIT BIH dataset, that means the imbalanced data, and the output will be the balanced dataset. So the first step is the initialization, And second one, identify the nearest neighbors. That means for each instance in the data set, we have to calculate the distance to all other instances in the data. That means the data distance metrics can be used here, the typical Euclidean distance, but it can be any distance measure suitable for this data. Then with the help of the Tomke links, we have to find out each and every the pairs of the instances. That means the X belongs to the minority class and Y belongs to the majority class. So we have to find out which pairs are affected by the Tomke links. After that, we have to remove each and every Tomke because the removal means which mainly aims to eliminate those minority instances that are in a close proximity to the majority classes. The main reason behind this is that we can eliminate in the confusion to the classifiers. And after that, we can calculate the class imbalance ratio. That is the third step. And here we have to find out the ratio of the class imbalance, means the number of the majority class instances to the minority classes. And the next step is we have to find out the neighbor selection, and we have to check the estimate the density distribution differences and calculate the density distribution difference. That is a sixth step. In the sixth step, we can calculate the density distribution difference between the minority classes and with its neighbors. And the seventh step is the estimate the density distribution of the difference. And here also we have to check the class importance minority classes. And the seventh step will be the calculate the importance of each minority classes. The importance means that based on the density distribution differences, we have to calculate the importance. We know the instances that are more dissimilar to their neighbors will have the neighbor importance. And the eighth steps will be the random undersampling. That is a third processing. In these steps, we have to create a balanced or nearly balanced subset of the data step. And mainly, these steps aims to reduce the dominance of the majority class and prevent the classifier from being the biased towards it. And we have to calculate the weight error and repeat these steps until the boosting process is complete. This is the overall procedure of my proposed hybrid algorithm. Here I am showing the comparison study of my method with another existing methods. In this slide, I have to show the differences between my proposed method and existing work. And here you can see that the bar graph displays the number of the instances or samples in each class after applying the existing algorithm. In the first graph, you can see the PCA applying result. Entirely, the data distributed are in the asymmetrical way. Like that, the Gaussian naive Bayes, KNN method. Likewise, the SVM, LDA, that means the linear discriminant analysis, and wavelet transform also shows the asymmetric distribution of the data. And this PPT shows the result and discussions of my proposed method. And in this figure, you can see that it will exhibit nearly equal sizeless slice values, which means it indicating that the data has been effectively balanced across the different classes. All the sections are 20%, that means the equally distributed. And here also you can see that each and every classes are distributed equally. So this is my proposed method and conclusion. The integration of Tomke links, rest boost and adazing techniques has proven to be the instrumental in addressing the challenges of the class imbalance within the Arrhythmia dataset. These methods collectively led to the creation of the balanced dataset thereby substantially enhancing the accuracy and the overall performance of our arrhythmia detection models. By strategically emphasizing the characteristics of the minority class, these approaches have paved the way for more robust and reliable classification system. This progress holds the great promise for the advancement of the arrhythmia analysis in clinical settings, potentially revolutionizing the diagnostic processes and facilitating the timely medical interventions. So this is about my newly proposed method, and thank you so much to give this wonderful opportunity to present my project topic in WIZT 2023 conference. Thank you.